Nope, this is not a painting by an abstract artist, but a real close-up of the swirling cloud bands that extend up to 3,000 kilometers deep into Jupiter's atmosphere. The fact that we can now marvel at this colossal gas giant in such an overwhelming level of detail is thanks to NASA's Juno spacecraft. Having plunged into the realm of the solar system's largest planet on July 5, 2016, Juno has since captured countless breathtaking images and has also uncovered a series of huge surprises that shed a completely new light on Jupiter and its companions. For example, the spacecraft has managed to solve a mystery about Jupiter's polar lights that has stumped experts for decades, and to prove that the moon Io, despite its extreme volcanic activity, has no magma ocean. Jupiter is a planet of superlatives. With an equatorial diameter of around 143,000 kilometers, the gas giant is about 11.5 times larger than Earth, and with almost 1.9 septillion tons, it weighs around 318 times more than our blue home planet. It contains over 70% of the total mass of all the planets in the solar system, and in theory, our earthly home could fit inside Jupiter more than 1,300 times. In practice, however, the gas giant not only has amazingly large dimensions, but also no less large mysteries. These concern, for example, the gigantic magnetic field of the Colossus, which, in the best Jupiter manner, embodies the strongest and largest of all the planets in the solar system. The situation is quite similar in the case of the atmosphere. Not only is it the densest in our solar system, but it also heats and crushes the high hydrogen it contains to such an extreme degree that the atoms dissolve and act like giant electrical conductors. No less mysterious, however, is what lies beneath the colorful, almost parallel bands of clouds. Experts suspect a solid rock core of up to 20 Earth masses here. And so it came about that the NASA Juno spacecraft had some truly exciting mission objectives in its luggage when it set off into the vastness of space on August 5, 2011. But that was not all. If we look at it very closely, we see that this is not an unmanned trip to Jupiter in the classic sense, but a research flight with 3 passengers. These may be made of plastic rather than flesh and blood, but the Lego minifigures of Galileo Galilei, the Roman god Jupiter, and his wife Juno are the first inhabitants of Earth to get up close and personal with the king of our planetary system. One surprise follows another. Why the Juno data has researchers baffled. Equipped with a titanium-plated shell to protect the sensitive onboard electronics from the immense radiation, on July 5, 2016, after a spaceflight of almost 5 years, Juno finally swung into orbit around Jupiter and immediately began to overturn everything we thought we knew about the gas giant. To say that the first Juno data came as a surprise to the researchers would be a massive understatement. The first measurements provided such astounding results that Scott Bolton, the principal investigator of the Juno mission, was quoted as saying, "The whole thing looks different than anyone would have thought before." I mean, no matter how we looked at it, we were shocked by what we saw. But what was responsible for this astronomical shock? On the one hand, the first images of the planet's polar regions showed that the gigantic bands of clouds that usually form regularly around Jupiter had completely disappeared. Instead, the experts were confronted with huge storm vortices, which stand out against the darker background like oversized spots and spirals. While the storm structures at the South Pole can reach up to 1,000 kilometers in extent, their diameter in the opposite polar region is as much as 1,400 kilometers. How these storms arise and why they look so different depending on the pole, however, was an open mystery for the researchers. But the fundamental appearance of Jupiter's polar regions was also puzzling, or rather, the fact that they differ so much from those of Saturn. While the iconic ring planet has pronounced ring currents at its poles, and its north pole is even graced by a striking hexagonal jet stream, Juno did not detect any structure on Jupiter that even remotely resembles such wind patterns. The polar dynamics and atmospheric structure of the 2 planets must therefore fundamentally differ from one another. But the 7,000 km wide cloud formation, which extends far beyond Jupiter's north polar region, also immediately raised major questions among scientists. The thermal measurements taken by Juno showed that the gas flows below the cloud cover are distributed quite differently than previously assumed. There is no largely homogeneous ammonia ocean slumbering here, but rather a columnar upwelling that forms a kind of ring around the celestial body. Remarkably, this circulation is very similar to Earth's Hadley cells, air currents that transport warm, moist air at the equator and allow it to sink as cold, dry air along the tropics. With regard to the magnetic field, Juno found that at around 7,766 Gauss, is not only twice as strong as previously thought, but also surprisingly lumpy. According to the experts, the fact that the magnetic field is stronger in some places than in others could indicate that Jupiter's corresponding dynamo is not as deep inside as it is in the Earth. More specifically, the field could be generated closer to the surface above a layer of metallic hydrogen. But if we are now delving into deeper planetary realms again, the question arises as to what the situation actually is with regard to the core. As already mentioned, scientists' models had predicted a solid rocky core in this regard, but there was nothing. Scott Bolton states, "We don't see anything that looks like a core. There may be a core of heavy elements, but it may not be all in the center. Maybe it's much bigger, maybe half the size of Jupiter. How can that be?" In fact, the Jupiter data suggests that the core of the planet is not solid, but rather a soft core in which the rock has mixed with the liquid hydrogen and helium of the inner mantle. So far, however, there is no clear explanation for this rarefied core. But one theory is based on the assumption that young Jupiter once collided violently with another protoplanet. How the mystery of Jupiter's polar lights was solved. It's undisputed that the Juno mission sometimes raises more questions than it answers. And yet, we should not forget that the probe's deployment has already played a major role in solving a number of long-standing mysteries about the planet. This applies, for example, to the mysterious interplay of the storm bands, which change their color and infrared brightness every few years. In this regard, the Juno data, in combination with model simulations, suggests that the secret change can be traced back to the cyclic oscillations in Jupiter's magnetic dynamo, which disrupt the heat transport of the surface and thus also the storm bands. The research into the northern lights was no less revealing. For 40 years, experts had puzzled over how they actually arise and why. Unlike their terrestrial counterparts, they don't concentrate in the so-called auroral oval between 65 and 80 degrees latitude, but extend right up to just beyond the poles. But after Juno plunged into the gas giant's magnetic field, and the European Exymnutian X-ray telescope simultaneously examined an aurora over Jupiter's north pole, it was clear that the auroras practically surf on the oxygen and sulfur ions on the polar magnetic field lines from one pole to the other. Just as wind is what drives surfers on Earth, here it is special electromagnetic ion cyclotron waves that accelerate the aurora in spurts, setting their characteristic pulsation in motion. So far, so enlightening. But in another area, experts are now facing a new mystery. Specifically, this concerns Io, the innermost of the 4 large moons of Jupiter, which is considered to be the most volcanically active celestial body in the entire solar system. Until now, researchers have assumed that the volcanic activity is fed by a huge global magma ocean, but apparently this is not the case. The Juno data shows that Io is home to several separate magma chambers. And this surprising finding has implications that extend far beyond the volcanic moon. And you're welcome to cover the subscribe button with your click now. Just press the thumbs up and click subscribe so you'll never miss a new video from us again. We'll see you soon.